How heat moves. Hot chocolate in a mug. It's too hot to drink. While it cools, let's see where the heat goes. Hot chocolate is made of little particles of matter. Atoms are joined together to form molecules, which clump together to fill the mug. We can't see these tiny molecules individually, but if we could, we'd see they are energetic. They constantly wiggle, jump around, and bump into each other. Heat is a form of energy, so adding heat makes the particles even more energetic. We heated the hot chocolate on a stove. Liquid at the bottom of the pot was closest to the burner and got hot first. As it gained heat energy, its particles bounced harder and took up more space. This made them lighter, so they floated up. Colder, heavier liquid sank down to replace the rising liquid. It too eventually got hot, rose, and replaced the liquid above, which meanwhile had cooled a little. Soon, the whole pot had currents of hot liquids rising and cooler liquids sinking. Heat from the burner was in this way spread throughout. Spreading heat through moving currents like this is called convection. Liquids and gases, such as air, often have convection because their particles move freely. When the hot chocolate was poured into the mug, it immediately began to lose heat. Some of the heat went to the mug, which was cooler. Heat always travels from hot to cold. Cold never spreads to heat. In the mug, hot chocolate particles bumped the inside edge. Heat transferred to the mug through those bumps, like billiard balls bumping one another on a pool table. In solids, such as the mug, molecules don't move freely like those in liquid or gas. Instead, they vibrate in place. The more heat energy, the more they vibrate. The vibrations can conduct energy neighbor to neighbor. In a short while, all particles of our mug have heat energy, and the mug feels warm. Heat transfer through particle-to-particle bumping in solids is called conduction. So the hot chocolate loses some heat to the mug, but more heat gets carried away in convection currents. The steam we see is made of superheated mini drops of water with so much energy they simply fly away from the water's surface and float up. These escaped mini drops continue to fly apart into ever smaller particles that soon become invisible airborne water, which we call humidity. While joining the air, the steam also transfers its heat there. The hot chocolate and mug also lose heat through radiation. Radiation is a different kind of heat transfer. Convection and conduction send heat energy through matter, gases, liquids, and solids. Radiation does not need matter because it travels in energy waves. The sun radiates heat through the emptiness of space in energy waves. When the waves meet matter, such as rocks and people, the waves deposit energy there and we feel the warmth. Radiant heat comes from lots of sources, including a campfire and hot chocolate. However, the chocolate and mug don't really give off much radiant heat compared to convection and conduction. Still, the heat loss adds to the total. So where does the heat go? It doesn't just disappear. Energy never does. Energy may move or change form, for example, from electrical to heat, but it always exists. In the hot chocolate's case, the heat lost through convection, conduction, and radiation, simply got swallowed in the vastness of the kitchen. With an accurate enough thermometer, we could have seen the kitchen temperature rise slightly. Unfortunately, we don't need a thermometer to tell us the hot chocolate is now just room temperature.